Hello everyone. So today we'll continue with the overall topic of trigonometry, and specifically we'll go over calculating angle measures with SOH CAH TOA, and a topic related to that is inverse functions or inverse operations. So in previous lessons we've worked with right triangle trigonometry, where we take a right triangle and one of its angles, label its sides opposite, adjacent, and hypotenuse, and then we have something called SOH CAH TOA, sine, cosine, and tangent, that gives us ratios of the sides. And we use those ratios to solve problems about right triangles and calculate things about right triangles. But so far in our lessons, we've only had to calculate side lengths. As in the problems we've done so far, the unknown was always a side length. So on this diagram here, the known info is a side length and an angle. We know them specifically, what number they are. And then the thing we're being asked to calculate is the second side length on here. The unknown is a side length. And now in today's lesson, we want to move on to problems where the unknown is an angle. So now on this problem on the right, we have two known side lengths. We know how long they are. And then the unknown, the thing we calculate, will be the angle. Because notice this y, it's a variable, it's our unknown, we don't know how many degrees it is. So compare these two. In one, the unknown is a side length, in the other, the unknown is an angle measure. Now, in both cases, how we start the problem, the setup for the problem is actually the same. So here's an example. Calculate the value of y. And regardless of whether our unknown is a side length or an angle, our goal here is still the same. We want to set up an equation and solve it. And to do that, first we have to establish which side is which. So we've got the angle we're working with here, even though it's our unknown, even though we don't know how many degrees it is. And then the sides, well, looks like 33 is the hypotenuse. And then 16 is the opposite side across from our angle. And so we can set up an equation the same way we did before. So we've got the sides opposite and the hypotenuse. Which ratio is that? Sine, cosine, or tangent? That's sine. So we do sine, and then always, it's sine of the angle we're working with. So sine of y, even though it's an unknown. And then that equals opposite over hypotenuse, so 16 over 33. Now, to calculate y, we want to do things to this equation to get y by itself, right? We want to solve for y. We want to isolate y. But to do that, to get y by itself, there's this sign in the way on the left side. Right, so we want to get rid of that sign on the left side so that y will be by itself on the left side. And the question is, how do we do that? So for that purpose, let's talk about a topic called inverse functions. So, inverse functions, what are they? Well, inverse functions are a generally important and fundamental topic in math. And actually, in your previous work, you've probably seen and worked with inverse functions quite a lot, actually. So inverse functions are opposite functions that cancel or undo each other. And again, you've seen these inverse function things before. So here's two simple equations, and I bet you know how to solve them. So first one, x plus 3 equals 14. Well, how do we solve it? Well, you want to get the x by itself, so you subtract 3 from both sides, right? But think about this. We're taking x, our unknown, and we're adding 3. So what is the opposite of addition? How do we undo adding? Well, the opposite of addition, as in the inverse of addition, is subtraction. So we take both sides and do the inverse of that plus 3 on both sides. So minus 3 on this side, minus 3 on that side. And the whole point is, the adding 3 and the subtracting 3, they undo each other, they go away, they cancel on the left side, leaving x alone on the left side. And then on the right side, we get a number, 11, which is our answer. What about this next one, 5x equals 30? So 5x, if you think about it, is 5 times x, right? X times this number 5. What is the opposite of multiplying by 5? What is the inverse of multiplication? Well, the opposite of multiplication is division. So to get x by itself, you divide both sides by 5. And now multiplying by 5 and dividing by 5, those cancel each other on the left side. And you get x by itself. And then on the right side, 30 divided by 5, our answer is 6. So if you think about it, oftentimes when we're solving equations, we're applying an inverse function to both sides. Couple more examples. We got x squared equals 64. So to get x by itself, we need to get rid of that power of 2, that's squaring. What's the opposite of squaring? What's the inverse? Well, it's square rooting. So you square root both sides. The square root and the squaring cancel, and you get x equals 8. What about square root of x equals 5? And you know the opposites, they go both ways. So the opposite of square rooting is squaring, taking it to the power of 2. Do that to both sides. The square root and the square cancel, and again you have x by itself. 5 squared is 25. So again, oftentimes when we're solving equations, we're applying inverse functions to both sides, and sometimes we apply a sequence or chain of inverse functions, right? So for example, this equation, what do we have to cancel first? So the minus 5, opposite is plus 5, so plus 5 on both sides. So first these cancel, you're left with 4x squared. And then what to cancel next? Next we have to cancel the multiplying by 4, so divide by 4, because that's the inverse of multiplying. These cancel, x squared equals 9. And then finally, one more thing to both sides, right? What's the opposite of squaring? Square rooting. So you do the inverse function, these go away, x is by itself, and we get our answer. So lots of inverse operations in sequence to get the variable by itself. And by this point in your math work, you've probably learned a bunch of these inverse function or inverse operation pairs, right? And it's probably good to have them in mind. So again, what's the opposite or inverse of adding a number? Well, that's subtracting that same number, right? And remember, this goes both ways. So the opposite of adding is subtracting, the opposite of subtracting is adding. What's opposites with multiplying by a number? Dividing by that same number. What's opposites with squaring? Taking something to the power of 2, square rooting. So now, of course, the question is, what's the opposite of these guys? What are their inverses? Sine, cosine, tangent. And so far, I've referred to these as ratios, but now let's think about them as the sine function, the cosine function, and the tan function. So what are the inverse functions? Well, it turns out mathematicians did not come up with fancy names for their opposites. So their opposites are literally called inverse sine, inverse cosine, inverse tangent. And so, for example, inverse sine is written like this. Sine with a little -1. Now, another name for this is arc sine. So inverse sine is the same as arc sine. And then the cosine function, the inverse of that is inverse cosine, cosine with a little -1, also called arc cosine. And then the inverse function of tan, again, inverse tangent, also called arctan. And so we're going to be using these functions over here to cancel these functions over there that show up in our equations to get the variable by itself. So here's an example. Determine the value of theta, and it's a right triangle, so we know we can use SOH CAH TOA. We have to set up our equation, which means we need to know what the sides are. So this is our angle we're working with. Looks like 7 is opposite. 16 is not the hypotenuse, and it's touching the angle, so it's adjacent. Which thing uses opposite and adjacent? It's tangent. So our equation starting out is tangent of our angle, even though we don't know it, tangent of theta equals opposite over adjacent, so 7/16. And now again, we got to get theta by itself, which means we need to cancel this tan right here. So let me rewrite this equation so we can keep the original up there. And so we need to do the inverse on both sides to cancel that tan and get theta by itself. What is the opposite of tan? Well, that weird inverse tan thing, right? Tan with a little -1. So both sides, tan, -1. So what's going on here? Inverse tan and ordinary tan cancel on the left side. So like we wanted, we have just theta alone remaining on the left side equals, what's going on the right side is we're taking that fraction 7/16 and applying the inverse tan function. So theta equals inverse tangent of 7/16. And so we have theta equals inverse tan of 7/16. That's just some number that we can use our calculator to find. So theta is around, and whatever this is in our calculator, it's going to be a weird number. And let me show you how to evaluate that on one type of calculator. And different calculators will have their own ways of typing that in. So here's a typical scientific calculator, and we've got your ordinary sine, cosine, tangent as buttons here. But if you look closely above the buttons, you have these small green letters. And if you look, it's the inverse functions, sine inverse, cosine inverse, tan inverse. And so to access those, on this calculator, you press the second button, and then our problem used tan. So second tan to get inverse tan. And our final answer was inverse tan of 7/16. So I've got it all typed in now. So I press enter and I get around 23.629 degrees. And to get answers in degrees, don't forget to have your calculator in degree mode. So back to the example, we had theta equals whatever inverse tan of 7/16 is. And in our calculator in degree mode, we got around 23.6294 degrees if we round. So that's our final answer, the angle measure we were looking for. And that's it for this lesson. Good luck.